equations with brackets and fractions. If an equation has brackets in it, then it is important to remove the brackets first by applying the distributive property, otherwise known as expanding or multiplying. You might remember doing the distributive property when you were in grade 9. Afterwards, you'll be able to solve the equations using inverse operations to balance the equation for each step. For equations with fractions, it's important to clear the fractions first. That makes our questions a lot easier to solve. And since a fraction means to divide, you can get rid of them by multiplying. And to eliminate all of the fractions at the same time, you multiply by the lowest common denominator or the lowest common multiple. And then to keep the balance of the equation, we have to multiply every term by that lowest common multiple. So let's see how that works. For each of these examples, we're going to not only solve the equation, so we're going to solve for x, or whatever the variable happens to be, but we're also going to verify our answer by using the left side, right side check. So the first thing we want to do for example number 1 is to apply the distributive property. So if you remember, that means that we multiply this value on the outside by everything inside of our bracket. And you may remember seeing it with like some arrows to sort of help you remember that you're multiplying by every term within the bracket. So this 3 times x gives us 3x. 3 times 1 gives us 3, so we have plus 3, and that is equal to 12. So once we've eliminated the brackets, this becomes a question that we know how to solve based on our previous lessons. So we're going to start by moving all of our numbers to the other side of our equal sign so that we can isolate that variable. So we're going to move our 3 over. So right now it's being added to the 3x. So when I bring it across the equal sign, I want to subtract it. And now, last couple of examples and lessons, we were looking at showing all of the steps, and that is definitely something that you can do. Another option is just to, when you write this step, is to, I'm just going to show you a different method. Sometimes it can be a little bit more efficient. So we can have 3x. And because we're moving this over, sometimes you might see it written like this. So 12 minus 3. So we've just eliminated that extra step right there. So 3x is equal to 12 minus 3. Let's simplify that. So 3x is equal to 9. And now we want to divide because it's being multiplied by the x. So the opposite of multiplying is dividing. So we're going to divide the 3x and the 9 all by 3, because whatever we do to one side, we do to the other. So sometimes you might see this now written just to make things a little bit more efficient. Sometimes people write that right at this step. So they show that they're dividing both of these at 3 by 3. So it eliminates our 3's on the left-hand side because 3 divided by 3 gives us 1. So we're left with just an x. And 9 divided by 3 gives us 3. So we have an answer of x equals 3. We're going to verify that answer by using the right side, left side check. So the left side of my equation is 3 times x plus 1. And the right-hand side of my equation is 12. I'm going to substitute in 3 for the value of x. So 3 times 3 plus 1. Simplify what's inside of my brackets first. So 3 times 4. 3 plus 1 is 4. And 3 times 4 is 12, which is exactly what I have on the right-hand side. So the left side equals the right side. Therefore, x equals 3. Example number 2, we have a negative 2 in front of our bracket. So that reminds us that we have to multiply by that negative 2 everything inside of that bracket. So I'm going to multiply by negative 2 by my x and my negative 2 by my 4. So this line will say negative 2x. So negative 2 times x is negative 2x. And negative 2 times 4 is negative 8. And that is equal to 14. So again, once I've applied the distributive property to remove the brackets, it becomes an equation that I know how to solve. So I'm going to move my negative 8 to the other side of my equal sign. The opposite of subtracting something is adding. So I'm going to add it when I bring it over. So I have negative 2x is equal to 14 minus 8, plus 8. So I've eliminated it from the left-hand side, and I'm moving it over. So this is just another sort of strategy. So instead of showing that negative 8 plus 8 on the left-hand side, we're just showing that plus 8 on the right-hand side. So now I want to simplify what I have on the left-hand or the right-hand side. 14 plus 8 is 22. And now when I'm dividing, because I have negative 2x times x, so the opposite is dividing, I want to make sure that I divide by the negative 2 because I want just a positive x remaining. So I'm going to always divide by the number and the sign that goes with it. So negative 2 divided by 2 is 1, so I'm just left with an x. And 22 divided by negative 2 is negative 11. So let's verify our answer by doing the left side, right side check. The left-hand side of my equation is 2 times x plus 4, and the right-hand side of my equation is 14. So negative 2, I'm going to substitute in my value of negative 11 in for my equation here. I can write 14 here if I want to. If I want to show all the steps, I can. That's fine. Then I'm going to simplify what's inside of my bracket. So negative 11 plus 4 is negative 7. And negative 2 times negative 7 gives us positive 14. Two negatives multiplied by each other gives us a positive value. The left side equals the right side, which is what I wanted. So x is equal to negative 11. Or therefore, x is equal to negative 11. Sometimes you might have brackets on both sides of your equation, and that just means we have to apply that distributive property not only on one side of the equation, so the left side, but also the right side. So we're going to now multiply our bracket on the left-hand side of the equation by 3. So I'm multiplying my b and my negative 1 by 3. And on the right-hand side, I have a 2 out front, so I'm going to multiply my b by 2, and then my negative 2 also by 2. So I'm showing that I'm applying the distributive property. This time I'm doing it on both sides of my equation to eliminate those brackets. So 3 times b gives us 3b, and 3 times negative 1 gives me negative 3. On the right-hand side, 2 times b gives us 2b, and 2 times negative 2 gives us negative 4. So now this becomes a question where we have variables on the left and right hand side. So we have variables on both sides. So it just becomes a question where we want to look at moving all of the terms with a variable to one side and all of the constants to the other side. And you can do this in one step if you'd like to. So the last lesson we did it one step at a time, which is perfectly fine. But I'm going to show you how you could do this in one step as well. So I'm going to move my 2b to the left-hand side. And right now it's being added because there's no sign, so it's a positive. So when I bring it over to this side, it's going to be a negative. When I'm looking at my negative 3, and I'm just going to draw my line up here so we can see the difference. So right now I'm subtracting it from 3b. When I bring it across the equal sign, I'm going to do the opposite of subtracting, which is adding. So I'm going to start with my 3b on the left-hand side, and I'm subtracting my 2b. I'm moving my negative 3 over, and I already have the negative 4 on this side. When I bring the negative 3 over, I'm adding, so it's plus 3. So 3b subtract 2b gives us 1b. So you may choose to write the 1 in front of the b, or you can eliminate that 1, that's fine. And negative 4 plus 3 gives us negative 1. So you can rewrite, you can leave it like this, 1b is equal to negative 1, or you can write b is equal to negative 1. So again, let's do our left side, right side check. On the left-hand side of my equation, I have 3 times b minus 1. On the right-hand side, I have 2 times b minus 2. I'm going to substitute in the value of negative 1 for my b. So I have 3, and then negative 1 subtract 1, and 2, negative 1 subtract 2. Simplify what's inside of my brackets. Negative 1 subtract 1 gives us negative 2. Negative 1 subtract 2 gives us negative 3. 3 times negative 2 gives us negative 6. And 2 times negative 3 also gives us negative 6. So the left side equals the right side. Therefore, b in this case, b is equal to negative 1. So now that we've looked at some examples involving brackets and applying the distributive property to eliminate those brackets first and then solve it using the strategies we've used in the previous lessons, we're going to look at some questions that are a little bit harder. So we have some questions that involve fractions. And now fractions can be a little bit daunting for some people, but I'm going to show you some strategies so that when you get equations with fractions, it's less scary. Because truthfully, once you've learned some strategies, hopefully you won't find them too difficult. So in example number 4, I have 6y minus 2 divided by 5 is equal to 2. So the first thing I want to do is this is an easier version of a fraction. We saw a question similar to this, except the numerator was just a single term in our first lesson when we looked at solving one-step and two-step equations. So this just is a matter of taking our 5 and bringing it over to the other side. So when we did this in our previous lessons, we would multiply both sides by our 5 to get rid of that fraction, right? So the opposite of dividing is multiplying. Another strategy to make your solutions a little bit more efficient is to simply just show that you're moving this 5 over, or just showing that you're multiplying it by the 5 times 2. We already know it's going to be eliminated when we do it on the left-hand side, so we can just show that work on the right-hand side. So we are left with 6y minus 2 on the left-hand side, because we're getting rid of this 5 on that side. And on this side, we have 2 times 5. So the opposite of dividing is multiplying when I bring it across the equal sign. So this is another strategy that you might hear. When I bring it over across the equal sign, I do the opposite sign, or the opposite operation. So now let's simplify what we have. So I have 6y minus 2 is equal to 2 times 5, which gives us 10. So now, once we've eliminated that fraction, it becomes an easier equation for us to solve. So we're going to start by moving our constant over to the other side. So right now, the 2 is being subtracted from, our 2 is being subtracted from the 6y. So that when we bring it over to the other side, or the opposite operation, is going to be addition. So we're eliminating it from the left-hand side. So we have 10 and then plus 2, because the opposite of subtracting is addition. So let's simplify that. So 6y is equal to 10 plus 2 is 12. And then we're going to do the opposite of multiplying to isolate the y. So I'm going to divide both sides by 6. So you might see it written like this, so that our 6's are eliminated from the left-hand side. 6 divided by 6 gives us 1y, and 12 divided by 6 gives us 2. So let's verify our work by using a left side, right side check. The left-hand side of my equation is 6y minus 2 divided by 5. The right-hand side is 2. So I have 6 times 2, so I'm substituting in the value for y. Subtract 2 divided by 5. 6 times 2 is 12. Take away 2 divided by 5. 12 minus 2 is 10 divided by 5. And 10 divided by 5 is 2. Which is exactly the same as our right-hand side. So the left side equals the right side. Therefore, y is equal to 2. We're going to go through 2 more examples just so that you have some more practice, so more examples to refer to when you're doing your questions. So the next one is 3y equals 20 plus 10y over 3. So this is one where we're going to have to multiply every term by our denominator. So we only have one denominator, so we're going to multiply everything by 3. Okay, so I'll show you what that looks like. So when we're looking at eliminating our fractions, we have to make sure that we balance our equations. So whatever we do to one term, we have to do to all the other ones when we're eliminating fractions. So the 3 is our denominator. So we're going to multiply every single term by 3. So we're going to have 3 times 3y. We're going to have 3 times 20. And we're going to have 3 times 10y over 3. So the 3 divided by the 3 will cancel each other out because 3 divided by 3 gives us 1. So we're just left with that 10y. So then the other terms are going to be multiplied still. So 3 times 3y is 9y. 3 times 20 is 60. And then we have our plus 10y. So in order to eliminate the fractions, we need to multiply every single term by the denominator if you just have one fraction. So exactly what we did here. So now what we want to do is we want to move all of our terms with a letter to one side and all of our terms with a number to the other side. You'll notice that the 10, the positive 10 is larger than our positive 9. So normally I would move my variables to the left-hand side, but this time I'm going to move them to the right-hand side because what that'll do, if the number, you want to try to move the variables to the side that has the larger value of y, so the larger coefficient, so that you are left with positive values instead of negative values. It just makes it a little bit easier. So we're going to move our 9y to the right-hand side. Right now it's a positive 9y, so when I bring it over it's a negative. And I'm going to move my 60 to the left-hand side. So right now it's being added to 10y because it's a positive 60, so when I bring it over it's a negative. So I'm going to have a negative 60 on the left-hand side, and on the right-hand side I'm going to have 10y, and I'm taking away 9y. So let's simplify these like terms. So I have negative 60 is equal to 10y subtract 9y gives us just y. So y is equal to negative 60. So if you had kept your y's on the left-hand side, you would have had negative y is equal to 60, but we don't want to leave it as a negative y, so you would have to divide both terms by negative 1, and you would have gotten the same thing, but you would have just had an extra step. So let's do our left side, right side check. The left-hand side is 3y. The right-hand side is 20 plus 10y divided by 3. Substituting in the value for y, 3 times negative 60. 3 times negative 60 is negative 180. The right-hand side, I'm substituting in the value for y. So I have 20 plus 10 times negative 60 divided by 3. So I'm going to multiply my numerators. So I have 20 plus 10 times negative 60 is negative 600 divided by 3. You'll notice I have a plus and then a minus. So this next line, I'm just going to eliminate those extra signs. So I have 20, and then negative 600 divided by 3 gives us negative 200. So I'm going to have negative 200 there. And 20 take away 200 is negative 180. So the left side equals the right side. Therefore, y is equal to negative 60. Last example. This is one of the harder ones. This is an example where our denominators aren't the same. So I have one that's a 4 and one that's a 5. So a over 4 plus 6 is equal to 3 times a plus 3 divided by 5. So this is where we're looking for that lowest common denominator. Sometimes you'll see this as a lowest common multiple as well. So what is a number that is larger than 4 and 5 that both of them will divide evenly into? So 4 and 5 will both divide evenly into 20. So that is the lowest number that 4 and 5 will divide evenly into. So once you've identified that lowest common denominator, we're going to multiply every single term in this equation by 20. So I'm going to multiply 20 by my a plus 4. I'm going to multiply 20 by my 6. And I'm going to multiply 20 by my 3 times a plus 3 divided by 5. By doing that, this helps us eliminate those fractions. So it eliminates our denominators. So 20 divided by 4. So 4 goes into 20 5 times. 5 goes into 20, or 20 divided by 4, or 5, is 4. Okay, so what I've done is I'm eliminating those fractions. So I've just taken my lowest common denominator and I've divided it by my denominators to give us a number that I can multiply by. So this next equation, a line of my equation, will be 5 times a plus, and I can simplify this, 20 times 6 is 120. And then I have 4 times 3 times a plus 3. So I've gotten rid of my fractions so that it becomes an equation that just has numbers being multiplied. So let's go ahead and simplify some of this. I have 5a plus 120. And I can multiply my 4 by my 3. So 4 times 3 gives us 12. And then I have to multiply that by a plus 3. So this becomes a distributive question where I'm multiplying my 12 by everything inside of my bracket. So my 5a plus 120 just stays on the left-hand side for a moment. 12 times a is 12a, and 12 times 3 is 36. So now I want to ask myself, which side of my equation has the larger coefficient for a? Well, 12 is larger than 5, so I'm going to bring my variables, so the terms of the variables, to the right-hand side. So that means I'm going to bring all of my terms with just a constant to the left-hand side. So I'm going to bring my 5a over. So right now it's being added because it's a positive term. So when I bring it across the equal sign, it's going to be subtracting. My 36, right now it's being added to the 12a. When I bring it over to this side, it's going to be subtracting as well. So what I'm going to have is 120, because that is already on this side, subtracting 36 is equal to 12a, because it's already on the right-hand side, subtracting 5a. So now it becomes a question that's a little bit easier to work with because I'm not going to have any negative coefficients in front of my variables. So 120 subtract 36 gives us 84. And 12a subtract 5a gives us 7. So the next thing you want to do is divide by the coefficient. So I'm going to divide both sides of my equation by 7 because the opposite of multiplying is dividing. So 7 divided by 7 gives us 1. There we go. So I'm going to write it up here. And 84 divided by 7 gives us 12. So I have 12 is equal to A. So because this is a really long question, I want to make sure that I've done this correctly by doing that left side, right side check. I know it seems a little tedious, but this is where it's really important because this is a question that involved lots of steps. So it's very easy for us to make a mistake, whether it's a sign mistake or a calculation mistake. So it's really important for us to do our left side, right side check to make sure that we've done this correctly. Because when you have a question on a quiz or an assignment, you're not necessarily going to get the answers. So this left side, right side check gives yourself a little bit of assurance. So the left-hand side is a over 4 plus 6. So I have 12 divided by 4 plus 6. 12 divided by 4 gives us 3, and 3 plus 6 gives us 9. The right-hand side is 3 times a plus 3 divided by 5. Substituting in the value for a, so 12 plus 3 divided by 5. Simplifying what's inside of our brackets, 3 times 15 divided by 5. Now you may want to do some simplifying. So 15 divided by 5 is 3. So 3 times 3 gives us 9. You could have also done 3 times 15 and then divide by 5 and use the calculator for that. This just helps you do a little bit of mental math in your head. So the left side equals the right side, which is what I wanted to see. So I can say with certain that A is equal to 12.